Bismillahirrahmanirrahim. Today's theorem is Theorem 14.1.3. But before going into the proof of that theorem, we need to recall a few results which we are going to use in its proof. Okay, so there are a few results which we are going to use in the proof of Theorem 14.1.3. So first we will have to understand that result. The result that we are going to use is Theorem 14.1.1 statement. Okay, only the statement we are going to understand so that we can easily use it in the proof of our theorem. The statement is that a line parallel to one side of a triangle. So here we are talking about a triangle. Let the triangle be A, B, C. Okay, we have a triangle and we have a line which is parallel to one side of a triangle. Suppose this is the side to which we have this parallel line. Okay, and let me draw a line which is intersecting the other two sides. Intersecting means here it is a line which is intersecting. Intersecting means cutting these two sides. Okay, this is the line which is parallel to one side of the triangle. Let L be the line. Okay, and let it be parallel to BC. So if you have a line which is parallel to one side of a triangle and it is cutting the other two sides, it is crossing or cutting, or more appropriate word in mathematics is that this line is intersecting these two sides. Okay, this line L is intersecting the line AB at this point and this point. Let this point be D and let this point be E. Now according to this theorem, a line parallel to one side of a triangle, this is the line which is parallel to only BC. Okay, this side only, not these two sides. It is crossing the two sides of the triangle and it is parallel to one of its sides, one of its three sides, and intersecting the other two sides, divides them proportionally. Okay, what does it mean proportionally? Dividing proportionally means equality of two ratios. Okay, whenever you hear the word proportional, it means we will be talking about the equality of two ratios. Now how it divides them proportionally? This line is dividing AB into two segments, AD and DB. Okay, it is divided and these parts may not be equal to one another. Okay, they may or may not be equal to one another. And this line L is also dividing this side AC in two segments, AE and EC. Now what does it mean that this line divides them proportionally? It means that this line will divide this side and this side in such a way that the ratio of these two segments will be equal to the ratio of these two segments. Okay, this line is dividing AB into two segments. L is dividing AB into two segments. We don't know whether these segments are equal or not, but it is dividing into two segments. One is AD and the next is BD or DB. Okay, these are the two segments, AD and DB. And L is also intersecting or dividing AC into two segments. What are the two segments that L is making on this line? When it crosses AC, it is dividing it into two segments, AE and EC. Okay, AE and EC. Now the two segments on AB are AD and DB. If you find the ratio of these two segments, AD over BD is the ratio of the segment which this line is making on AB. Okay, and this will be congruent to the ratio of these two segments. Okay, the ratio of the segments AD and DB, AD over BD is the ratio of these two segments. Okay, and AE over EC is the ratio of AE over EC is the ratio of the segments which this line L is making on AC. Okay, so these two ratios will always be congruent, and this equality or congruency of two ratios is called proportionality. Okay, this line will divide AB and AC in such a way that the ratio of these two sides will be equal to the ratio of these two segments. The ratio of these two segments will be equal to the ratio of these two segments. Okay, AD over DB will be congruent to AE over EC. So this is called the proportionality. Okay, equality of two ratios is called proportionality, and if this line L divides them proportionally, it means that it will divide them in such a way that there will be equality of some ratios. Okay, so we have to remember this result which we are going to use in our theorem. The result is that if you have a line, okay, which is parallel to one side of the triangle and it is intersecting the other two sides. Okay, this line must intersect the two sides of the triangle and it must be parallel to the third side, not one of these sides. Two sides will be intersected by these lines and one side will be parallel to this line. Then the segment which it cut off from each side will be proportional. Okay, we will use this result in our theorem. So let's go to the proof of Theorem 14.1.3. We had to use this result in it. That's why first we made clear this statement, because we are going to use this statement. Okay, we will have a line parallel to one side of the triangle, and in that triangle we are going to use this ratio. We are going to write the ratio between these two segments will be equal to the ratio between these segments. Okay, this is the result that we are going to use. We will be having this condition, and I will use this result from this theorem in the proof of Theorem 14.1.3. So let us start the theorem. So Theorem 14.1.3, the statement is that the internal bisector of an angle of a triangle. So you have a triangle, you take an angle of that triangle and you are bisecting that angle. Okay, so we are talking about the bisector of an angle of a triangle. Here we have a triangle. We have the triangle, let it be A, B, C. Okay, and we are talking about the bisector of an angle. Let A be the angle, okay, and draw a bisector of this angle. Okay, we have an angle, we have a triangle ABC. Okay, triangle ABC, we took an angle of it and we drew the bisector of this angle AD. Okay, AD is the bisector of this angle A. Now what does the theorem says? The internal bisector of an angle of a triangle divides the side opposite to it. Okay, this bisector will cross the side which is opposite to this angle. This is the angle and the side opposite to this angle is BC. Now this angle bisector is dividing BC into two segments, BD and CD. So how it is going to divide? It divides the side opposite to it in the ratio. It means that the ratio of these two, BD over DC. Now we are talking about the ratio of these two segments divides the side opposite to it in the ratio of the lengths of the sides containing the angle. Okay, containing the angle means that the sides between which this angle is made. Okay, these are the side AC and AB are the sides which is containing the angle A, because these are the two sides with the help of which angle A is made. So we say that angle A is contained between these two sides. Okay, so what they are saying is that the internal bisector of an angle of a triangle divides the side opposite to it. Okay, it is dividing into two segments. These segments may or may not be equal. Okay, we know nothing about their equality, but we know that there definitely will be two segments and what they are saying is that it will divide the side opposite to it in the ratio. Means that this ratio will be same as the ratio of the lengths of the sides containing the angle. These are the sides which are containing the angle A. So this ratio of these two segments is equal to the ratio of the sides between which angle A is contained. Okay, the two sides between which the angle A is made, there the ratio of these two sides will be the same as the ratio of these two segments. This is what we need to prove. Okay, so they have given us a triangle ABC. We have an internal bisector. Bisector means these two angles are definitely going to be equal to one another. Okay, angle 1 and angle 3, they are going to be equal to one another. We will take angle 2 as in the construction. Okay, so these two angles will be congruent because it is AD is the bisector. It is given to us, a triangle ABC is given to us. We have an angle A. Okay, we have taken angle A and we have a bisector of this angle. If this is the bisector of the angle, it means this line will divide this angle into two equal halves. So it means that measurement of angle 1 will definitely be equal to measurement of angle 3. Okay, these are the things which are given to us, and we have to prove that this line intersects the side opposite to this angle in such a way that the ratio between these two segments, okay, which this line is making, will be the same as the ratio between the sides. Okay, these are the sides containing the angle A, and these are the segments which are made by this angle bisector on BC. So the ratio between these two sides and these two segments and these two sides is always equal. This is what we need to prove. For that, we will have to do some steps of construction. Now let us go to the proof. I will write the key points. Okay, this will be given and this is what we need to prove. So we have a triangle ABC. We have the angle bisector AD, which is dividing this angle into two equal angles, angle 1 and angle 3. Okay, triangle ABC, it is given to us. AD is the angle bisector of angle A. As it is the bisector of angle A, it will divide A into two equal parts, angle 1 and angle 3. Both these angles are going to be equal. Intersecting BC at the point D. It is intersecting the side BC at the point D. Now we need to prove that BD over DC, the ratio between these two segments is the same as the ratio between the sides AB and AC. Now we will going to do some construction so that we are able to prove our theorem. The construction is that we are going to draw a line parallel to AD which will pass through B. Okay, draw a line which is parallel to this line AD. Okay, parallel to this line AD. This is the line. We will draw a line which is parallel to this line AD. Okay, and we are going to extend this side AC until it meets the line. Should be somewhere here. Okay, take this point as E. Okay, where these two lines meet. So you are drawing a line that is parallel to this line. You are drawing a line BE parallel to AD. These two are parallel lines. Okay, and then you are extending AC to a point where the line which you have drawn, the parallel line, meets this side. Okay, you are going to extend side AC. So this is what we are going to do in the construction. Draw a line BE. Okay, you are going to draw a line BE parallel to AD, and then you are going to extend AC to a point E. Okay, you are going to extend this point, this side AC, until it meets the line BE at the point E. You can write this as well, and this is also enough to write. Okay, now in order to start the proof, and you are going to name the angles which are here and here. Name these angles as angle 2 and angle 4. Okay, these are the angles, angle 2 and angle 4. Now what we are going to do is, first of all, we will make these two angles congruent. Okay, this will be the first step. After making these two angles congruent, it will be clear that AB is congruent to AE. Okay, side AB is congruent to this AE. Something like this. Okay, so we will make these two sides congruent, and with the help of this we are going to get our result. Okay, these are the 2-3 steps that we are going to do. Let us start. First of all, consider the lines AD, okay, and BE. AD and BE, these are two parallel lines. Okay, and this is the transversal which is intersecting these lines. Okay, consider the lines AD, the parallel lines. Okay, these are parallel because we had done this in construction. AD parallel to BE. Consider these two lines. These are parallel to one another, and AB is another line which is crossing them. Okay, and AB is the third line which we often call as transversal. AB is the transversal, intersecting these lines. Okay, we did all this in construction. Now we have two lines AD and BE. Okay, let this be point A, D, and this be point E. Suppose this is point B. There is a transversal AB crossing them. Okay, now angle 3 is between this bisector and this line AB. Okay, this between AD and AB we have angle 3, and angle 4 is between this line BE, okay, and AB. Between BE and AB we have angle 4. So this is the picture that we are having over here. Now as you see, then they are the alternate angles formed by two parallel lines. We know that AD is parallel to BE because we did this in construction. So we have the line AD, okay, and the line BE, and AB is the transversal which is crossing them. Okay, if I draw this over here, you can easily see that these two angles are alternate angles, and we know that whenever two parallel lines are intersected by a transversal, then the alternate angles so formed are always congruent. Okay, so I'm going to write this result that angle 3 is congruent to angle 4 because they are the alternate angles formed by two parallel lines. Okay, we are going to write angle 3 is congruent to angle 4. Alternate angles. It's enough to write just alternate angles. The whole story is that whenever two parallel lines are intersected by a transversal, then the alternate angles formed by those lines are always congruent. Okay, so measurement of angle 3 is congruent to measurement of angle 4. Now again consider the parallel lines AD and BE, but this time the transversal is not AB. We are going to take another transversal, and that is we are going to take these two lines. Okay, AD, this is the line AD, and the line BE. Okay, this time I'm not going to take this transversal AB. I'm going to take this transversal AE. Okay, AE, if I extend this line, okay, yes, and join AE. Now these are the parallel lines AD and EB, and consider this transversal AE, or you may say EC. Okay, let me draw C also. It will be somewhere here. We have joined AE. Okay, and let me take this point A is here, so it, okay, and then we have a point C over here. Okay, so we have two parallel lines, okay, AD and BE, and this is CE is the transversal which is crossing these two parallel lines. Okay, now angle 1, this is the angle made by EC and AD. Okay, EC, let me draw it correctly. Okay, this is something like this. Okay, the angle between AC and AD is angle 1. Okay, and the angle between EB, okay, and EC, EB and EC, this angle is angle 2. Now as you may see, this is the line, okay, this is the transversal which is cutting these two parallel lines. Okay, we have two parallel lines, okay, and this is the transversal cutting them. As you may see, as I have described earlier in the previous videos, that these two are corresponding angles, and the corresponding angles are always congruent. Whenever two parallel lines are intersected by a transversal, then the corresponding angles so formed are always congruent. Okay, alternate angles are also congruent and the corresponding are also congruent, and this is the result that I am going to use here. Okay, so consider AD is parallel to BE, and a transversal EC is intersecting them. So angle 1 will be congruent to angle 2. Okay, angle 1 will be congruent to angle 2 because they are corresponding angles. Now I can erase this. The reason for this is corresponding angles. Okay, now name this as 1, this as 2, and now I'm going to write another equation, but measurement of angle 3 is congruent to, or angle 3 is congruent to angle 1. This is given to us. Okay, angle 1 and 3 are congruent because AD was the bisector. This was given to us. So this is what we have written from given. Now angle 3 is congruent to angle 4 and angle 1 is congruent to angle 2. As angle 3 and angle 1 are congruent. Okay, so replacing 3 by angle 4 here because they are congruent. Angle 4 is congruent to angle 1 is congruent to angle 2. So I can replace angle 1 by angle 2. Okay, so what result do we get over here? The result is that angle 4 and angle 2 are congruent. So we have got this result that angle 2 and angle 4 are congruent. Okay, angle 4 and angle 2 are congruent. This is from let this be 3, from 1, 2 and 3. So this is the main result that we want. Let me name this as 4. Now as angle 2 and angle 4 are congruent, so the sides opposite to, if you consider this triangle ABE, triangle ABE, opposite to angle 2 we have AB. Okay, opposite to angle 4 we have AE. So AB is opposite to 2, AE is opposite to 4. 2 and 4 are congruent. This means that these two sides are also going to be congruent. Okay, because the sides opposite to congruent angles are always congruent. It means that AB is congruent to AE. This is because sides opposite to congruent angles of the triangle. Let me mention the triangle also, ABE. Okay, so this is the result number 5. Now only one step is left which will complete this theorem. What we did is that we first took these two parallel lines, and this was the transversal, which gave us the result that angle 3 is congruent to angle 4. Now again taking these two parallel lines, the same parallel lines, but this the second time you are going to take this transversal. Okay, this is also a line cutting these lines, which will give you the result that angle 1 and angle 2 are congruent because they are corresponding angles. Now angle 1 is congruent to angle 3. These three results will give you that angle 2 is congruent to angle 4. After this, we will get the result that AB is congruent to AE. Now in the final step, you are going to understand why we are making AB congruent to AE. Okay. The final step is that you are going to use Theorem 14.1.3. Okay, let me erase this. So we are just going towards the last step. We are going to use this equation in it. Okay, so I will write this equation again. I won't write the reason again because I have already written it. We have the reason, we have the result AB congruent to AE. Okay, this was equation 5. I'm going to use it now. First of all, consider triangle CEB. Okay, consider the triangle CEB. Now if I erase this line, okay, let me erase this line so that you can, I will draw it again, but here I want you to see the triangle CEB. Okay, you have a triangle CBE in which AD is parallel to its sides EB. Okay, AD is parallel to BE and it is intersecting the sides CB and AE, CB and AE, CB and CE at the points A and D. Okay, this is what we did in construction and we can easily see it from the figure. Okay, we have triangle CBE and this is the line AD which is parallel to the third side of the triangle, and it is intersecting the sides CB and CE at A and D. Okay, so we have this triangle. Okay, this is the triangle. This is a line which is parallel to the third side of the triangle and it is intersecting these two sides. Okay, so from theorem 14.1.1, which I discussed in the beginning of this theorem, this lecture, that if you have such that you have a line which is parallel to the one of the sides of the triangle and it is intersecting the other two sides, then this line will always cut these two sides in such a way that the ratio of these two segments CD and DB, okay, these are the segments formed by this line on the side CB, and AC and AE. Okay, these are the segments formed by this line on the side CE of this triangle. We know that these two segments are always congruent to these two segments because this line is parallel to this side and this line is intersecting these two sides. Okay, so it means that BD over DC, measurement of BD over DC will be equal to measurement of AE over AC. Okay, BD over DC is equal to AE over AC. This is from Theorem 14.1.1. Do write the statement of that theorem, okay, that I have already written in the beginning of this lecture. We are going to write the whole statement. Okay, what was the statement? That if you have a line parallel to one side of a triangle and intersecting the other two sides, then that line divides the two sides proportionally. Okay, this will be the statement of the theorem that you are going to write. It is written in your book. So write the statement. Okay, and let me name this result as 6. So if you look at this statement and this statement, the only thing missing is that this is BD over DC, BD over DC. Here we have AE instead of AB, and we have AC. Okay, so all these three are same, only AB is missing. Now we know that AB is congruent to AE. Okay, we had already proved this. Let me draw AB again here. We have already proved that these two sides are congruent. This was the reason why we proved it. Okay, because we wanted AB over here. We wanted to use this theorem. From this theorem we got the ratio, or this ratio, but the only thing which is missing is AB. Okay, here we have AE and here we have AB. If I can replace AE by A